Alright guys, we're now looking at target 3.4. Our math learning objective is I can find measures of inscribed angles and find measures of inscribed polygons. So an inscribed angle is angle whose sides are chords. So we had our central angles before, and those sides were radii, right? So an angle whose sides are chords. So the vertex is on the circle. Here it's very important to know what on the circle means. On the circle and in the circle are two very different things. So we're not on the circle, we're actually talking about a point on, right, the curve that makes up the circle, right, where these points are in the circle. And so the circle itself is really just the outer set of points, right? And then the intercepted arc, we kind of seen these up already. It's just the arc between the endpoints of the angle. So here's my angle. This would be that intercepted arc. Same thing here. And this is just three cases. All three of these pictures are of an inscribed angle. It just shows you that the diameter is a chord, so it could be part of the part of your inscribed angle. That center point could be between the two chords, or they both could be to one side of the chord of the center. So just make sure we kind of recognize that all of these are inscribed angles. So let's look at an example. If an angle is inscribed in a circle, then the measure of an angle equals 1/2 the measure of its intercepted arc. Okay. So really what we're saying is here's angle 1. Angle 1 is half of the measure of this arc. All right, different from our central angle, right, is equal to this arc. And you can tell if you draw that this angle is much skinnier than this angle. Okay, so that's how we get that was 1/2 of it. So, looking here, finding the measure of angle P. That is that is angle P, so I'll put an X there. So again, I like to say the measure of the angle equals 1/2 the measure of the arc. We don't have to really put in the names of them, but just making sure you know the angle goes over here and the arc goes over on the right. So our angle is our X, and our arc is 70. Then I'm just multiplying those, and we get 35 degrees. Okay. Same thing with part B. I'm finding the measure of arc PO. So I'll put a Y there. And this is the angle that creates that arc, right, that intersects that arc. So the measure of the angle equals 1/2 the measure of the arc. Oh, I'm going to measure. The angle is 56 degrees. In order to get rid of this 1/2, I'm going to multiply both sides by 2. Right, in a different color. Right, that way this 1/2 and this 2 cancel. I'm left with Y equals, and 2 times 56 is 112 degrees. this lovely picture, find the measure of arc CF. Well, here's arc CF. So I'm going to go with C, and I'm going to follow the line, and then to F. Right, so that's the angle that intercepts this arc. So you're basically just kind of connecting it in a different way. So that angle is 40 degrees. Measure of the arc. So the measure of the angle is 40 degrees. X. This is another one where I'm just going to, to get rid of that 1/2, I'm going to multiply both sides by 2. Okay, so this cancels, I'm left with x equals 2 times 40 is 80 degrees. Our next one, measure of angle C. Well, here's angle C. I'm going to follow the lines out. Right, there's its intercepted arc, where those endpoints are. Measure of the angle. Measure of the arc. So here our angle is x. And the measure of our arc is 98. And that gives you 49 degrees. Okay, let's look at our next theorem. Our congruent inscribed angle theorem. If two inscribed angles of a circle intersect the same arc, then the angles are congruent. Right? So what this is saying is, if I look at angle B, right here, it ends at A and D. Angle C also ends at angle D, or also ends at A and D. So therefore, they both create the same arc. And so therefore, angle B and angle C are the same. Right? So if we look at example 3 here, right, angle T creates this arc. Angle U creates this arc. This arc is the same arc. So therefore, angle T is equal to angle U. Right? And so 3x minus 5, this should actually say congruent. Angle T is congruent to angle U. So 3x minus 5 is equal to 2x plus 15. So this is similar to kind of what we did yesterday, right? With making a lot of things equal to each other. So I'm going to subtract 2x from both sides. So I have x minus 5 equals 15. So those cancel. Add 5. X equals 20. But again, we want to find the measure of angle T. So the measure of angle T equals 3x minus 5, which is 3 times 20 minus 5. 3 times 20 is 60, minus 5 is 55 degrees. Alright, last theorem that we're going to look at today. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay. So in quadrilateral KLMN is inscribed in circle A. So quadrilateral just means a four-sided shape. Right. And Inscribed just means every point of that four-sided shape is touching the circle. So that means angle L and angle N, the ones that are opposite of each other, are supplementary. So they add to 180. And then same thing, K and M, the ones that are opposite each other, add to 180. So, looking at example 4, quadrilateral WXYZ is inscribed in circle V. Find the measure of angle X and the measure of angle Y. Well, let's start with the measure of angle X. Angle X is opposite that 60 degrees. So the measure of angle X plus the measure of angle Z will equal 180. So that's X plus 60 equals 180. So X equals 120. Same thing with if I'm finding the measure of angle Y, well, it's opposite that 95 degree angle. So the measure of angle Y plus the measure of angle W. Okay. So Y plus 95. So Y equals 85 degrees. Okay. Okay, there's one other question that I thought, type of question that I thought I had on here, but it's not. So I'm going to quickly draw one in. This board stops jumping around. So I'll call it example 6. Okay. And we're going to draw a lovely picture. It's a lovely circle in our center. And this goes with this one. This is an inscribed quadrilateral. This is an inscribed triangle, right? So this, we say A, B, and C. Okay, so angle B is going to be 80 degrees. And arc BC will be 120 degrees. And then I want to figure out what, oh my gosh, sorry, angle C is. That's going to be my X. Okay. So one thing to remember in this that we've used before is that triangles add up to 180 and circles add up to 360. Both of those types of things could help you in problems that are similar to this. But when I look here, right, I see that I have this angle of the triangle. I want to find this angle of the triangle. If I knew angle A, then I'd be able to use the idea that these angles add up to 180. Okay. So what I'm going to do is go, well, if I look at angle A, this is my arc that creates angle A. So let's put a Y right there for now. Then, right, the measure of the angle equals 1/2 the measure of the arc. So Y equals 1/2 of 120. So Y equals 60 degrees. Now, X plus 60 plus 80 equals 180. X plus 140 equals 180. If I subtract 140, X equals 40 degrees. Okay, so you might see problems like that. These are still just inscribed angle problems, but also having to use maybe the fact that they add up, that a triangle adds up to 180. Okay. All right, and that is it. I'll see you guys tomorrow. Have a good rest of your day.